Okay, guys, I hope your day has been awesome and we're ready to start. Let me start sharing my screen. Share screen. Uh-oh. Not this slide. Let's start from the beginning. Okay. Let me see. Okay, so here we go. So we are about 36 participants. So this class is going to be about frequency distribution. And I hope you have a better understanding of how you should, once you have your sample, how to view it on a histogram or on a frequency distribution. Now let me just share my screen. Share screen. Here we go. So do you remember what we talked about last class about the Fruit Loops and how you could get a sample with different randomness? So one of them was kind of like pulling a couple for every color, having kind of like divide the sample into groups. That way we'll have the same chances from picking a blue one, a green, a red. So the frequency distribution is going to help us organize the data. So what do we mean by frequency distribution? So frequency is only how often something occurs. It's just how many times it repeats. So for example, if we have the Fruit Loops on this graph, the frequency will be 2, 4, 6, 7 times. What about the red ones? The red ones will be 6. And then the orange will be 6. And the blue ones will be 2, 4, 6, 8, 9. So the frequency of the blue ones will be 9. So if I ask you, and we're talking about a sample. So whenever we're talking about a sample, we're going to use, do you remember which letter? The letter N. So if I ask you, can you, how will you do like frequency distribution on the blue, the green, the red, the purple, and the orange? Those will be our color classes. So usually you will do a table just like this. So usually you're gonna put yellow, how many times, and the colors in our core classes. It could be a type of group, or it could be just a characteristic. So in this case, we use the colors. So I want you to know that these are for a sample. So whenever we use our sample, it's the letter N, which is the variable, because it could change. Like, don't get too nervous about a variable, but it just means that it could change, like the number, it could change. So what will be our total N? So we're gonna add 5, 6, 4, 3, and 1. That'll be what, 19? 10, 8, yeah, that'll be 19. So this is a very common graph where it's very important. And I decided just to make one graph for the STEM group. That way we'll get more practice with it. So let's start. So what do we want to graph? So we want to graph, I decided to do the group STEM because we're familiar with it. And I ask you about your ages too. So we're just gonna graph how will be the frequency of how many people between each age, and you'll see more. So if we're talking about our population, I thought this will be a cool example. So if our whole population, it's all of the high school students, our sample could be our STEM group, because you guys were chosen because you guys have specific characteristics. So that could be our sample. So out of the 21,280 students, 976 were picked to be from our STEM group. So we have ages from 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 20, 19, and then we got teachers that are 22, 30, 31. Let's see. So from the questions that I asked you or the data that I collected, I found out that the minimum age that we have on our group is 10 years. And the maximum, counting me, don't ask how many years I am, but the maximum is 30 years. So if we got a sample collected from the STEM, this will be another sample. So what letter do we use for our sample? Little n or lowercase n. And whenever we add, if we add all the samples together, so for example, if we go back, remember over here we got a 19 for our letter N. What will be our letter N or the value of our letter N over here? So I got that we got 69 students. So I got the answer from 69 students. And whenever we add all our sample data, or whenever we add, like there's an addition, we use this like Greek letter. It's like a Z, or no, more like an E, more like an E. So that's the icon for addition on statistics. So the very most important part is what information do we want to extract from the data collected. So if we only have one group, so do you remember on the Fruit Loops, we got 1, 2, 3, 4, 5 different classes. We got 5 different classes because we have the colors. We wanted to know what was the frequency of the colors. So what do we want to graph? We want to graph, if we have all these students that they have different ages, we want to see how will our frequency graph will look like for each age. So if we have one group, will that tell us anything? Probably not. We're only gonna say, okay, all of these 69 students are just in one STEM group. So what about if we have one group per person or one class per person? Group and classes are the same. We're gonna have 69 groups, which we're not gonna get a lot of information. So it's very important. That's the first thing that we need to know. Like, how many groups do we wanna have? How many classes we wanna have? So on the cereal boxes was 6 because we got 6 colors. But on this exercise, I decided to separate them into 8 classes. So that's gonna be our range is gonna be 8 classes. And whenever we have more data, like 1,000 data points, or we're collecting more information, you're able to see if there is a trend. If there is a trend or if there is an outlier, something that was specifically for that day that the machine didn't work, and that's why we have a lot of rejects. Or with the visual graphs, we're able to see how our data is like fluctuating. So that's why it's important. It's very important to have the number of classes. You don't want to have too many, but you don't want to have too much. So I decided to divide it into 8 classes. So that's our step 1. So we have our frequency table. So our step 1 is deciding how many classes. So our step 1 will be 8 classes. I don't know if you want to start drawing like a just like one line, two line, like one perpendicular line that will say the age, and I'm gonna explain it more. So I divided into 4 steps. The first step is getting the classes. This will be the second step. The second step will be getting our class width. Over here it should say step 1, not step 2. So our step 1 will be usually given to you either by your professor or by this time by me, by your instructor. So this is the most important part. You wanna start with your class width. So between classes, we're gonna have, let me see. We're gonna have a lower class limit and an upper class limit. So what do you mean by lower class limit and upper class limit? So for example, in this case that we're gonna see your ages. So the maximum age that I got was 30 years. And the minimum age that I got is 10 years. So in order to get our step 2, which is our class width, we're gonna have our maximum value, which is 30, minus our minimum value. How much is that? Can someone do the math? So it's 30 minus 10, that's 20, divided by the number of classes. And the number of classes was given to you, which is 8. So 20 divided by 8, how much is it? The chat's working.
Are they sending them in?
Huh?
Are they sending the answers in? I can't see.
I'll wait like 2 minutes. So this is how we get our class width. So our class width will be the maximum value of the data that we got, which in this case is 30, minus the minimum value, which in this case is 10, 2.5. Okay, I got answers from Benicio, Ori, Jane, Toby, Stopper, Ramaya, Kay. 2.5, that's correct. So you'll be like, wait a minute, but that's the decimal point. Usually you're gonna get a decimal point. It's very rare that you're gonna get a whole point. But you're gonna divide the classes into those, so we're always gonna round up. We're always gonna round up. So in this case, we got 2.5, so we're gonna round up to 3. So that's our class width. So step 1, we got it, which is 8 groups. So I want you guys to start also your frequency table, because we're gonna have some homework. So step 1, we got 8 classes. So we're gonna make 8 lines. So 1, 2, 3, 4, 5, 6, 7, 8 lines. And then our step 1 will be dividing 30 minus 10 divided by 8, because this was given to us. So the answer, 2.5. Well, we're always gonna round off, so it's 3. Okay? Following me? So our class width is very important. So our class width will be the difference between, so I hope you guys can see it. So our class width will be the difference between the two classes level. It could be the difference between the lower class level or the upper class level. So what do I mean by lower class level? So lower class limit is the smallest value belonging to a class. So we're gonna have 8 classes. So for the Cheerios, the classes that were colors. But for this chart, the classes are gonna be ages. So and then I decided to divide those ages into 8 groups. So we're gonna have a range, right? We're gonna have the minimum, and then, so in this case, the lower class will be the lower the lower value belonging to this class. And then the upper class limit will be the higher. So let's just start so that way you get a better idea. So we said, so what will be the lowest value in our first class? So we said that the lower value was 10, right? So we said 10. So we're gonna start with 10. And then we have our class width. So our class width is 3. So over here, we're gonna have all the ages that they are 10, 11, 12, and 13. Oh no, that's 4. 10, 11, and 12. So that's 3. So 10, 10, 11, 12. 10 to 12. And then, can we have 12 here? No, because if we have 12 here, we're gonna count 12 here and 12 here. So we're gonna start with 13. And then we add our class width. 13, 14, 15. So we're gonna add 13 to 15. So our step 3 will be lowest value in first class. So what will be our lowest value in first class? So we said it was 10. And then we said step 4, largest value in first class. What will be the large value on the first class? 12. Very good, Ori. 12. So I have a quick here. 10 years, 11 years, and 12 years is our class width, which is 3. Very good. So, can someone tell me what will be here? Let me give you a quick tip. So the class width, very good, very good. I'm getting some answers. So the class width is really important. So we said that the lower class limit, so you just add 3. 10 plus 3 plus 3, 16 plus 3, 18. So plus 3, 19, 18. What will be, but this is where, 21, very good. This is where people get confused. The class width is not between here, it's between classes. So the class width, it'll be between class 1 and class 2. It's not between here and here. Okay, so you guys can tell me the answers for this one? (22 to 24). Number 6. Well, 22, 23, 24, that's correct. And then plus 3, 25 to 27. And then 7, very good. 28 to 30. 8. 31 to 30. Okay, so Now we're gonna check our frequency. So this is the results that you guys send me. So I got 6, 31, 27. So most of you guys are between 13, 14, 15, and 16, which it makes sense. And then we got 1, 0, 0, 1, and 0. So if we were gonna graph this, so Ori is asking why we have an extra class down here. So this is like a piece of bread. So whenever you slice a piece of bread, you have to start somewhere. So whenever you cut a piece of bread, you're gonna get two ends. So you're gonna have one extra. Whenever you start slicing data, you're gonna have one extra, and we're gonna go through. I'm gonna show you. We're not done yet, so I'm gonna explain it a little bit more. Sorry, yeah. Step 4 will be just someone's asking me what will be step 4. Step 4 will be just finding the largest value on the first class. So this will be step 1, how many classes? Step 2 will be finding your class width. And then once you have your class width, you can start populating everything. So you start from the lowest and then go down. Or you could start with your highest and then go down. And then your piece of bread will be, you're gonna have here an extra one. Okay, so let's continue. So now we're gonna talk about class boundaries and the midpoints. So the class boundaries will be, we're gonna make a histogram. That will be one of our homeworks. So what's a histogram? A histogram is it's a graph. Well, let me show you. A histogram, let me show you really quick because I want you to know what's a histogram. So a histogram is between, we have a bar graph and we have a pie graph. What would be the difference between these two graphs? Someone's asking me, how do we know how many classes to use? That's always gonna be given to you, either by your professor, by your instructor, or by your book. They're always gonna tell you on this type of exercise how many classes to use. This case, I decided to use 8. That's correct. So Jacob is saying that one graph is for percent and the other one is for total number of people. So a histogram is kind of like having these two graphs together. So we're gonna have bar graphs, but they're having space in between one another. So in a histogram, you're not gonna have space in between one another, and they're gonna have to add to 100. So in order to have that, we're gonna have our class boundaries. So you see, like over here, you have 12 and 13. So in order to not to have this gap, we're gonna have to find our class boundary. Can someone tell me what will be the number between 12 and 13? 12.5, very good. So that'll be our class boundary between this one. So for example, what will be our, like if we, let me go back to the slides. That way we continue. So I kind of say our class boundaries. Our class boundaries are the gap between classes, which is this gap between 12 and 13, and it's only used for the histogram. That way we're gonna have no gap. And I'm gonna go over the homework at the end, so don't you guys worry. And it's gonna be due on Friday. Yay, our first homework. So class midpoint. But I want you to get this concept first. Don't get too wrapped up on the homework. I first want you to understand this concept. That's the main point. So class midpoint. Well, what do you think is a class midpoint? So we're talking about classes. This is a class. This is a class. What do you think will be the midpoint for a class? Yeah, your midpoint of class 1 is 11. That's correct. That's correct. Guys, you're very So that will be the upper class limit plus the lower class limit divided by 2 between the same class. So that how did he got 11? 10 plus 12, that'll be 22 divided by 2, that's 11. That will be the same. Let's just do it. So this be, we're gonna do another one. Our class midpoint, midpoint will be 11, 14, 17, 20, 23, 26, 29, and 32. Are there any questions on what would be the difference between a class boundary and class midpoint? Okay, if not, I'm gonna, so how many class boundaries do you think we're gonna have? 8, right? Because we got 8 classes. Same with midpoints, 8 midpoints. So this was what we were doing, 12 plus 13 divided by 2. That'll be 12.5. Class boundaries. So our class boundaries, let me put them over here. Class boundaries. So we said from 12 to 13 was 12.5. 12.5 over here, 15 and 16, 15.5, and then 18, 19, 18.5. Well, have a lot of space over here. 18.5, 15.5, 12.5, 21.5. Are you getting the same? Yes. Well, how do we got the frequency? The frequency was, I kind of like send the question asking your guys' age. And this is our, like how many, will be the same with the Fruit Loops, like how many green ones, how many blue ones. So how many people are between 10 and 12 on this group, on our STEM class, year 3, 6. Between 13 and 15, 31. And between 16 and 18, we got 27. We got one that's 21, which is Alexis, which is our assistant in case we need anything. She's awesome. And then we got one that's 30, that's me. And then I got another question. How many boundaries are we gonna get? Let's find out. 1, 2, 3, 4, 5, 6, 24.5. We should get 8. So if we're gonna have 8 classes, we're gonna have class 8 midpoints and 8 boundaries. So we got 27.5, and then we got 30. So, okay, can someone tell me what would be the difference between 12.5 and 15.5? 3, that's correct. And what's our class width? 3, that's correct. So if I'm gonna have, so where does my class start? Like if I have another, like the piece of bread, if I divide this into 2, so 12.5 minus 3, that'll be 9.5. So this is where the piece of bread starts. So we cut it here. So we're gonna have some that below it. And then same goes here. 33 point. Okay, so let's continue. I think you guys are pretty smart and are getting it. So we did already our class midpoint. So histogram. I have a quick video just to explain what will be a histogram. Can you see it? I think I have it here.
This table, we have 2 rows. In one, we will have the class interval, which will be the price range of pens. And in the second, we will have the frequency, that is the number of pens sold of each range. So these are the different class intervals that are given. First range is pens that cost between 10 and 20 rupees. We can see that the upper limit of one interval is equal to the lower limit of the next interval.
Are you seeing my screen?
As it's continuous, the first group would mean 10 rupees.
Let me see how can I.
No, we aren't.
You are?
No, we aren't.
Okay, let me.
Okay, yeah, we can see now.
Okay.
This table, we have 2 rows. In one, we will have the class interval, which will be the price range of pens. And in the second, we will have the frequency, that is the number of pens sold of each range. So these are the different class intervals that are given. The first range is pens that cost between 10 and 20 rupees. We can see that the upper limit of one interval is equal to the lower limit of the next interval, making it continuous. As it's continuous, the first group would mean 10 rupees is less than or equal to the price of the pen, which will be less than 20 rupees. The lower limit is included, but the upper limit is not. So in the second group, 20 is included along with all numbers less than 30, but not equal to 30. In the second row, we have the number of pens sold for each category. 15 pens of this category were sold, 20 of this category, and so on. Until now, we have seen examples of bar graphs, but never seen bar graphs used to represent continuous form of grouping. Let's see how we can do that. The first thing that we do is draw the x and the y axis. We draw the axis and make equal intervals on each of them. Then we label the axis. Since we want to represent the quantity of each class interval, we have the pens sold in the y-axis and the price range of pens on the x-axis. The steps are similar to the ones we used to draw a bar graph. Now we have to choose a suitable scale for the y-axis. The number of pens sold range between 5 and 30. A scale of 1 centimeter equals to 5 pens on the y-axis would be perfect, as we would need just 6 divisions. We start writing the values on the y-axis. 5, 10, 15, and so on up to 30. And on the x-axis, we start writing the price range of pens. The first range is 10 to 20, then 20 to 30, and so on up to 50 to 60. That's it. Now we just have to draw appropriate bars for each class interval. For the range 10 to 20, the frequency is 15. So based on the scale, we draw a bar of length 3 centimeters. For a frequency of 20, we draw a bar of length 4 centimeters. And we continue the process till we reach the last range. This is called the histogram. Bars used to represent continuous class intervals. Remember, for bar graphs, we did not have intervals here. We just had plain simple categories. But here, we have intervals on one axis and quantity on the other. What we did here was simple. We choose a scale and draw bars for each continuous interval. But note that the intervals were continuous. 20, which is the upper limit of the first interval, is used as the lower limit for the next interval. But what if the intervals are discontinuous? We will understand that in another video.
Share screen. Okay. So
Hey team, Justin Zeltzer here from
we don't need that.
where today I'm responding to a challenge that was issued to me. Someone asked.
Okay. Let's go back to sharing my screen. Can you see my screen now?
Yep.
Okay, good. So basically a histogram is not a story on Instagram. It's a histogram. So I was explaining to you like it's between, I hope that video didn't confuse you because it kind of like confused me a little bit. So a histogram is between a bar graph. It's basically a bar graph, but without those spaces. Those spaces are gonna be our class boundaries. So we could have, for example, you can see on this frequency graph that most of our students are between here. So that graph is gonna look like that, which most of our students are here, like are right here, if we graph it. And then we have, it could be skewed to the right. We could have 30 years, or people with 30 years old, if we have 30, then it will be here. But what we want, or what we are trying to achieve, or it's, this is called normal distribution. So this is your mean or your average. And then you have pieces that are either under or either lower, but very close to your mean, or very close. So this is what we want most of the time. So I have here a couple of examples. So one's histogram skewed to the left, skewed to the right, and there's like the normal. So this is what we want. Looks very pretty, looks smooth. So now let's do a histogram. So now that we got our frequency table, we got our, let's just graph it. That way we'll get a better idea. So which one do you think we should use? So if we got our X and our Y, what do you think will be our X? Someone's asking, how do we get the class boundary? The class boundary, that's really important. Let me go back. Let me go back really quick. So the class boundary is the gap between classes. Yeah, you're right. So on the X, we're gonna have our classes. And then we have, so this is our class. And class boundaries is the gap between classes. So it's the gap that we have between this one and this one. You can see that on the video, the gap that she was talking about was 20 and 20. Do you remember that? So there was like no gap in between. But these ones are ages. So after you turn like 7 years old, you start counting, you start counting your age like as, oh, I'm 29 and a half, or I'm 11 and a quarter. You just say, I'm 15 years old, or I'm 16 years old, or at least that's what I got. I got 15 years old or 16 years old, or some that are 15, almost turning 16. So our class boundary will be the gap between two classes. So over here, our class boundary will be 12.5. So it is 12, 12.5. But yeah, and then if we go back to our X will be our first class. So we could either say, we could either put the range, will be 12, 10 to 12. And then we're gonna have here a gap, which is gonna be the 12.5, and then 13 to 15. But on histograms, there's no gap. There's no gap here. So what we're gonna put over here is gonna be our midpoint. So you remember how to get our midpoint? Our midpoint was the upper class limit minus or plus the lower class limit. So 10 plus 12 divided by 2. So in this case, that was 11. So instead of putting like 10 to 12 and close your class boundaries, we're just gonna put 11. We're just gonna put 11. And then over here, we're gonna put 14. And then we're gonna have, whenever we slice the bread, we're gonna have here some other data or other minimum rejects or minimum, so 11, we said our class width was 3. So now 11 minus 3, 9. So we're gonna have 9, 11, 14, 17, 20, and then we're gonna have our frequency over here. Quick question. Can someone tell me what's our little letter, N? You guys remember what was our letter N? I'll wait a couple minutes. Y, 69, that's correct, 69. 69. So what about if I divide 6 by 69? What about if I divide 31 by 69? 27 by 69? Can someone divide 6 divided by 69? And then 1 divided by 60, 1 divided by 60. 10.3. Sorry, I'm running out of space, but we got 10.3. What about 31 divided by 69? Maybe I could put it here. This will be our relative frequency. Relative to what? Relative to 100%. So our total, we said it was 69. So this one, we said 10. Thank you, Benicio. So this one is 0.0. Okay, 0.0869. And then 7, 94. And then the next one, which is 27 divided by 69. Point 34. Okay, how is this one wrong? Seems kind of wrong. And then 0.014. And then this one is 0. This one is 0. And this one's 0.014. 0. Can someone do this one again for me? Class 2, it's 0.449. That's correct. So if we add 0.008, 0.449, 0.34. Thank you, Jocelyn. And then now add 0.0869 plus 0.449. The relative frequency, what we did in order to get this one, we divided the frequency divided by our n, which was 69. So our relative frequency, we divide the frequency divided by n, which in this case was, we got 6 divided by 69, because that was our n, 69. So 27 divided by 69 is 0.391. Okay, 0.391. Okay, can someone add for me 0.0869 plus 0.449 plus 0.391 plus 0.014 plus 0 plus 0 plus 0.0514? I'll wait. It's a long addition. 0.8829. $1.19. See, it's very important that we keep at least 3 decimal points, because we're talking about we're talking about the population, and then we're talking about a sample, so that we are ready. So if we want to get information about the whole population by testing our samples, or we want to make conclusions out of our sample for the whole population, we need to be very specific. So that's more correct. 0.154, 1.196. It's averaging, it's about 1. So what does it mean? 1. So this, it's adding 100%. So our relative frequency, it's 100%. So this is kind of like our bar or our pie chart. Okay. So I just wanted to explain you this one, the relative frequency. I really don't have a slide for it, but I just wanted you to understand that since we got our frequency and we divided by the total, adding up all these numbers will give us our n, which is 69, which is our 100%. And I wanted you to show you really quick. So now it's gonna time to make our histogram. Okay, let me just go. So we said that it could be skewed to the left, skewed to the right, or skewed normal. So that's what we want, normal distribution. But this one probably is not gonna be normal distribution. So we also said, that we were gonna build it like this. 9, 11, 14, 17. That way we don't have to put like the ranges, like 12 to 12.5 and then have a gap. So that way we'll include all this one. I just like to put like the middle point. So let's do it. So over here, we say we're gonna have 9, and then 11, and then 14, and then 17, and then 20. And then 4. I kind of had it over here. So I had 9, 11, 14, 17, 20, 23, 26, 29. And then we could have another one here. 29 plus 3, 29, 32. And then over here, I got my, my frequency. So how many we got under 9? That's 0. And then 11, we said 6. So we go back and said 6. And then the next one, 31. So we go up. The next one, 27. And then the 20, we go 1. Then we got 0. If we got 0, do we grab something? No, I just leave it. We just leave it blank. 26, blank. 29, 1. Is this the graph that you got? So if we want to draw a curve, that's basically how it will look. Okay, so if I ask you, can you do a frequency distribution for, because this is going to be the homework. You're going to make a frequency distribution and a histogram for your family members in year. So you're going to call your grandma, say, hey grandma, how old are you? Because I have a homework. And then we're going to start with step 1. Step 1, how many classes? So in this case, for homework, they're going to be 8. I have a slide and probably I'm going to send a file just to explain it, displaying the homework. But if I ask you what will be your step number 2, getting your class width. Do you remember how to get your class width? That will be the maximum. I don't know how, who will be the oldest in your family, minus the youngest in your family. It could be, so it will be, I don't know, maybe 50 minus 10 or 50 minus 2, 50 minus, and then divided by 8, because we're going to have 8 classes. And the number that we get, we're always going to round up. We're always going to round up. And then we start with our lowest value. So if our lowest value was 10 or 2, that will be our first H. So that will be 2. And then, so if we're going to have 2, what will be our class width? Do we add 10 plus 3? Or width will be the difference between class 1 or class 2? So if we have our class width, we only going to add 3. So that will be the difference between classes. So 10 plus 3, same with the midpoint. So you can start with the midpoint and then add 3, or you can start with the smaller, lower class limit. So you got 10, and then you got your class width is 3. So 10, 11, 12. So that's 3. And I don't know what number are you going to get here. Maybe you're going to get a 4.5. You're going to, or 4.6 or 4. So if you get a 4.6, you round up. If it's 4.3, you round up. Always round up. So you're gonna round up to 5. If it's 4.1, you round up to 5. So you're gonna have 10, 11, 12, 13, 14. So there'll be 14. Okay, so let's continue with art class. I hope you get these concepts enough. I'm gonna have the recording that you could go through, or you could just ask me a question and I'll be happy to answer. Okay, so we're talking about a population and a sample. So we talk about the population will be the whole high school students in all San Antonio, Texas. And we talk about our sample will be our STEM group. And the mean or average will tell us a lot of information. So what I want you to get here, there are these two variables. So the U, it's called mu. It's a Greek symbol for population mean, and sample mean. It's kind of like an X bar. We'll go through it next class. We're gonna see more of these Greek letters. So why are these graphs important? We can tell a lot of information from our mean or our average. So whenever they give you your scores for the whole semester, you get an average of a lot of your classes, right? So why a histogram it's important, so you can see how the data is behaving. So someone make a quick experiment, and I got you a couple of questions. So I got 3 scenarios. So we got 3 lines. Imagine it's a grocery store. Which line will you pick? We have one line that we have the regular line, like a bank line. So you have 3 cashiers, and you have one line. One person is waiting, and then you have a big line. So the first person waits probably 1 minute, and then the second one will make an exercise. And then the middle, you see, it looks like a target. So you have one person that's guiding and say, go to this cashier, go to this cashier. And they're kind of like wait about the same amount of time. Or you got the regular cashiers that you got you got 20 cashiers, and then you pick one, whichever one you want, and then you stay in there. So let's imagine there are 3 lines at a grocery store, and there are 3 different scenarios. One line is one big line, or one line and one person is kind of like guiding, or the other ones that you got 3 different lines like cashier. So, and then we're gonna have some variation. So what would be the variation? The variation is the highest minus the lower number. So if you're like me, like I always, so this me will be, so first we have 3 persons. We have Mia, that it's the first one on the first scenario. So we have three different columns. What will be for the first line? So on the first line, Mia waits 4 minutes, and then Alexis waits 7 minutes, and then me at the end of the line, I wait 10 minutes. And then we got the target line that we got a helper. So Mia, Alexis, and myself, we waited 7 minutes. We waited the same amount of time. But then we got the HV line that probably I got the same luck. So Mia gets there, picks 1 minute. And then Alexis gets there, picks 1, 3 minutes. And then I get there all the time, is the slowest cashier. So I wait 17 minutes. So can someone help me get the average of each scenario? Can someone add up 4 plus 7 plus 10 divided by 3? And then can someone else add 7 plus 7 plus 7 divided by 3? And then can someone else add that HB 1 plus 3 plus 17? Very good. So number 1, the number 1 weighs an average of 7 minutes. Number 2 weighs an average of 7 minutes. Number 3, very good guys. All of them are 7, that's correct. But this type of graphs or histograms will tell us more information about the data that we just collected. So you can see that we're gonna have variation in between lines, so the variation will be the highest minus the lower number. So over here on the HEV line, I waited 16 minutes compared to other lines that we could wait 0 minutes. So it's very important. The average will tell us a lot of information, but there's also like the variation that we need to consider, and the range. And we're next class, we're gonna learn more concepts and hopefully it will make more sense. But I just want you to, every time you have an statistics class, always pick statistics, because we use statistics in everything. And the more you know, the more familiar you will get with it. And something that we're afraid is because we don't understand it. So I want you to understand why this is important and where you can use it. Mainly you can use it in everything. And yep, now we have some homework. So I can like explain you a little bit about the homework. So I want you to ask all of your family members their age. I want you to ask your nephews, your nieces, your uncles, your aunt you haven't talked in a while, and say, hey, I have a homework. What's your age? It's okay if they lie. At least we got something. But I want you to ask if you have lucky to have your grandparents, your brothers, sisters, mom, dad. And so step 1, I'm gonna give it to you, which is separate into classes. So the classes, yeah, include yourself. Please include yourself. So the number of classes will be 8, and then we get the class width, which will be the highest minus the lowest. And then we start our frequency distribution. Will be step 3, we'll be getting our lower class limit, our upper class limit. What about if I have big family? Well, that's like on our STEM class, we got 69 students. So the more you have, I'll say that's very lucky. The only thing that's gonna change, it'll be the frequency. So yeah, that's lucky. And then step 4, we're gonna find our class boundaries or our class midpoints. And yep, 8 number of classes, and this is due on Friday. And I would like you to do a histogram too. Remember how we did our histogram? Just basically over here, we put our midpoints. So our midpoints was 9, 11, 14, 17. Mainly our midpoints were this ones. But we do have to end we're gonna have some data above 29 and below 11. Like the slicing a piece of bread. And that's it, guys. I'm just gonna stay for a little while to answer some questions through the chat. And let me know if you have any questions, and I hope you're getting more idea of how statistics are very useful. And just send me your questions. Thank you guys for watching. Yes, please. I don't know if I have not tried if you could send it through Remind app. If not, my email will work. That will be monica.my last name, ELBJORN @utsa.edu. I think I can send you guys my information. That way you could send the homework. That would be just easier. And I'll also probably send you a Word document, just mainly with a graph, and you could print it out and take a picture, or you could do it by hand. It's up to you. where do we access the recording? I don't know. They have upload them to UTSA. I can send you the website, or let me give it to you. Is UTSA future.utsa.edu/prep. And then you're gonna, if you click there, you're gonna see year 3. And so far we have had 2 classes. This will be our 3rd class. And it takes about 2-3 days to upload to UTSA. But I usually share the YouTube video after we're done with the class. That way, if you have any questions, you can just take a look at it. So I'll share the link as soon as we are done. Okay, any more questions? Thank you, guys. Yes, UTSA has the videos too. I think today I saw them and they were uploaded. Have a nice afternoon. Bye.